Okay, here we're solving for u. This is solving a linear equation with several occurrences of the variable. The variables on both sides and fractional coefficients. So this is just a review where we're solving for an unknown variable where we want to simplify both sides of the equation first and then use opposite operations in order to isolate u and solve for u. So the first thing we want to do, this is a pretty ugly looking equation, and it's probably going to come out with a pretty ugly answer as well. But remember to always check your work by plugging it back into the original equation to verify that you got the correct answer, especially if it looks weird. Okay, so let's go ahead and look at this. I see that we have fractions. We have 3 as the denominator, 3 as the denominator, and 4 as the denominator. In order to get rid of the fractions, we can just multiply by a common factor. The least common factor here, 3 times 4, is going to be 12. They both share that factor. So if I'm able to multiply both sides of the equation by 12, I can get rid of the fractions and it will look a lot nicer. So I'm going to go ahead and rewrite it here. Negative 7u plus 2/3 is equal to negative 5/3 times u minus 7/4. So what I'll do is I will multiply both sides by 12, because essentially what we're saying here is, with an equation, what we're saying is this side of the equation is equal in numerical value to this side of the equation. That's what an equation says. This equals this. So if we're going to manipulate the equation, whatever we do to one side, we have to do to the other in order to maintain that balance, in order to maintain the truthfulness of this equal sign. So what that's going to look like is 12, we're going to distribute to both the negative 7u and to the positive 2/3. Anytime you have parentheses and it looks like this, because when you're multiplying both sides, we have to multiply everything on that side by 12. That way everything is still equal and balanced. So the 12 is going to go to the negative 7u and also to the positive 2/3, and then over here to the negative 5/3 u and then negative 7/4. And what that's going to look like is we're taking a positive 12 and multiplying by negative 7u, and a positive 12 times a positive 2/3. And that is equal to a positive 12 being multiplied by a negative 5u over 3, which is the same as negative 5/3 u. It's a different way of writing it. And a positive 12 times a negative 7/4. So then we can evaluate each of these, each of the sides by evaluating the multiplication here. 12 times a negative 7u is going to be a negative 84u. And then a positive 12 times 2/3, you can either go 12 times 2, which is 24, divided by 3 is 8, or you can see that these both have a common factor of 3, and once you factor that out, you would be left with 4, and 4 times 2 is 8. So positive 8 is equal to 12 times a negative 5u would be a negative 60u, divided by 3 is a negative 20u. And then we have a positive 12 times a negative 7, which is a negative 84, divided by 4 is a negative 21. So negative 21. So now it's a little nicer looking. We have variables on both sides of the equation. First, we want to make sure they're simplified, which they are. Each side is simplified. A negative 84u and a positive 8. These are not like terms. We cannot combine these, nor can we combine a negative 20u and a negative 21. One has a variable, one does not. So they're simplified on both sides, but now we want to isolate the variable to just one side. So because I don't like really dealing with negatives, I'll take the smaller number and move it over. So we're going to start with a negative 84u. At this point, we're going to use opposite operations in order to manipulate the equation. So if I have a negative 84u, then we would use opposite operations, add 84u. What we do to one side, we have to do to the other in order to maintain the balance of this equation. So when we have a negative 84u and we add 84u to it, these cancel, giving me 0, but my positive 8 comes down. We didn't do anything to that. Is equal to negative 20u, but then we add 84u to that. We'll have a positive 64u. And then minus 21, nothing happened here. Okay, so at this point, we have the u isolated to one side, the variable, but we want to get rid of these accessories. We want to wait until the end to separate the coefficient from the variable, where it gets a little bit hairy. So first, we'll take care of this negative 21. Opposite operation tells us to add 21 to both sides. And you're starting to see that it's going to be a pretty ugly number. Negative 21 and a positive 21 cancel. My 64u comes down, nothing happened here. Equals 8 plus 21 is a positive 29. And finally, we can separate the coefficient and the variable using opposite operations. 64 times u, opposite says to divide by the coefficient, and we would do that to both sides. 64 over 64 cancels, leaving me with u is equal to 29 over 64, which is a terribly ugly number, and it does not simplify down. And you will find that if you were to plug this number back into the original equation here for u here and u here, you would verify that both sides are equal to about negative 2.505 and some change. They are equal to both sides, so u does in fact equal positive 29 over 64.